Hello, welcome to Mrs. Patterson's Homework Help. We are on Chapter 8, Lesson 1, and we're going to be going into prime and composite numbers, factors, and all kinds of fun things with multiplication. So it is my recommendation, as we get started on this lesson, it's a good idea to have a multiplication table handy. Now, I put one inside of plastic sleeves so I can, mark all over it, and then erase it, and you have a fresh copy for each time you have a problem. So it's a real good idea to have a multiplication table handy. They also have very large multiplication tables that go up to like 20 by 20. Those are kind of nifty too. But really, basically, you need just a 12 by 12 multiplication table. Okay. All right, so today's lessons are factors and multiples. Factors, you think of factories. Those are numbers that build other numbers. For instance, 2 times 3 equals 6. So the two factors of 6 are 2 and 3. Another way to get to 6 is 1 times 6. So then I know that also 1, 2, 3, and 6 are all factors of 6. Okay? So those are the two different ways that I can get to 6. Sure, you can do 3 times 2 and 6 times 1, but basically your factors are 1, 2, 3, and 6 for the number 6. Okay? Okay. So, multiples are numbers that grow. For instance, if you had multiples of 2, you have 0, 2, 4, 6, 8. Those are numbers that grow. It's kind of like a snowball. It starts with nothing and gets bigger and bigger and bigger. Okay? Okay. Now that we know what factors and multiples are, there's different ways that we can figure out what certain factors are for a number. And here they have 12, and they have a problem here. Let's go ahead and look at the problem. Mr. Carlton has 12 pictures to put on the bulletin board in his classroom. List the factor pairs to find how many ways Mr. Carlton can arrange the pictures in an array. Now remember, these are arrays, okay, where they have boxes, so many boxes one way and so many boxes the other. Okay, so we have to think of the ways that we can get to 12. Always 1 times 12, right? And then we could do 2 times 6 and 3 times 4. So there's that many different arrays. That's the 1 times 12, the 3 times 4, and the 2 times 6. So those are the 3 different ways that he could arrange the pictures. So we can say that the factor pairs, or the factors of 12, are 1, 2, 3, 4, 6, and 12. Notice how I put them in numeric order. That's kind of important because that way it keeps your information organized. So I picked it out and I put them in order. There's a lot of factors for 12. Okay. Alrighty, so they want us to find the factor pairs for each number. First of all, number 47 is the first one, and they only have 2 spaces. So they believe that there's only, or correctly believe that there's only 2 factors for 47. Well, why is that? Well, first of all, we can look on a multiplication table. Can we find the number 47 on this multiplication table? Well, I'll save you a little trouble. You can't find it. And the reason being is there's only 2 factors for 47, the number 1 and the number 47, because the only way we can get there is 1 times 47 equals 47. So the only way, because they're only giving us that, is 1 and 47. This actually makes this a prime number. Prime numbers only have 2 factors, 1 and itself. Okay? But we'll get to that in another lesson. Let's move on to number 78. 78, I can take my multiplication chart, and can I find 78 here? Well, let's look. I have 77. 78. I'm not seeing it. So does that mean it's a prime number? No, because look at all the options they give us here. So you are going to have a problem sometimes finding your number on the multiplication table. Now, if you had a really big multiplication table, you'd probably find it. Well, the first thing that we know we can do is we can get there by 1 and 78, right? 1 times 78 is 78. But looking at 78, I see that it's an even number. So if I took 78, I can evenly divide it by 2. So let me do that real quick. Goes in there 3 times. Hey, guess what? 2 evenly goes into 78. So I can do 2 times 39. Okay, because 2 times 39 will give me 78. Now I'm thinking, well, I've got 2 more here. What could I do? Could I try it by 3? Can I get 3 into 78? Let's try it. 2. Aha! 3 times 26 will get us to 78. 3 times 26. Make sure I got it right. But there's one more. What could that be? Well, we've got 1, 2, 3. Would 4 go into 78? Hmm. 4 doesn't evenly go into 38. I can get in there 9 times for 36, so that doesn't work. I know 78 can't be divided by 5 because it doesn't end in a 5 or a 0. What about a 6? Aha! 6 times 13 gets me to 78. Notice how I had to go beyond that multiplication table to get all the possible combinations for 78. Okay? This one would be a little easier because I know I can divide that by 5. And then they give us 3 more on the back. Oh, look, there's only 2 possible ones, so we know that that is 1 times 71, and that's going to get us to 71. That makes that a prime number. Okay? So, now we get to write yes or no for exercises 7, 8, 9, and 10. Is 43 a multiple of 7? Well, you're going to count by 7s. Look here. Guess what this does for me? 7, 14, 21, 28, 35, 42. These are all multiples of 7. These are all multiples of 8, 9, and so forth. So what was the question? Is 43 a multiple of 7? 42 and 49, so no, it's not. Okay? So look through and see if you can answer the other ones. You might have to go beyond your multiplication tables. Okay? Alrighty. And let's see. Model math. They want you to show how that would look. Write a definition for factor pairs. What are factor pairs? Okay? Well, 2 times 3 equals 6. 2 and 3 are a factor pair. Okay? And go ahead and try the test practice. Our bonus for today is find the factors, all the factors for the number 24.